Let's talk about how we construct a confidence interval for a population mean and how we interpret it. So just like with the confidence intervals for proportions, there are two ways to write confidence intervals for a mean. The first way is x bar, the sample mean, plus or minus the margin of error. So x bar, remember, is the sample mean, and E is the margin of error. So for example, an article in Journal of Marine Sciences found that the confidence interval for the mean number of shark bites per year was 88.3 plus or minus 12.1 with a 95% confidence. What's the sample mean and margin of error? So the sample mean is 88.3 shark bites, and the error is 12.1 shark bites. So, as before, that means our lower bound is 88.3 minus 12.1, or 76.2 bites, and our upper bound is 88.3 plus 12.1, or 100.4 bites. The second way is to write it as an inequality. So we say the lower bound is less than the population mean, which is less than the upper bound. So if they give us just the endpoints, like for the second way, how do we find what the sample mean is? Well, just like finding the sample proportion when we only have the upper and lower bounds of the endpoint, we take the lower bound, add the upper bound, and divide the result by 2. And the margin of error can be found two ways. We can take the sample mean and subtract the lower bound, or equivalently, we can take the upper bound and subtract the sample mean. So let's do a couple examples. The Gallup organization reported that the mean number of hours worked by adult Americans each week was between 42.7 and 44.5 hours. Find the sample mean and margin of error. So here, the sample mean is given by the lower bound plus the upper bound divided by 2, which is 42.7 plus 44.5 divided by 2, or sorry for the coughing, my allergies have been horrible recently. Anyway, that gives us 43.6 hours. Okay, to find the error, and remember, just like I said in finding the margin of error for a confidence interval about a proportion, we should check both ways of calculating the error to make sure that we got our sample mean correct. So the first way, we can do x bar minus the lower bound, which is 43.6 minus 42.7, which is 0.9 hours. And the second way is to do the upper bound minus the sample mean, and that gives us 44.5 minus 43.6, which is again 0.9 hours for the margin of error. Okay, we need to talk also about the requirements that have to be met before we can create our confidence interval. So, of course, the sample must be obtained randomly, and the sample size must be small relative to the size of the population. We'll just quickly go over what the calculator wants in this video, and then in the next video, we'll actually do some examples. So to find the confidence interval for a population, we use the following in the calculator. We hit the stat button, then we scroll over to the tests menu, and then we pick option 8, which is T interval. And the input that the calculator wants depends on whether we have the summary statistics. So remember that summary statistics would be our sample mean, our sample standard deviation, and our sample size, or whether we have the raw data. So if we have the raw data, a list of numbers that we have to put in L1, where the calculator has INPT, we're going to put it on data. And I'll show you how that goes in the examples when we pull up the calculator. For list, we're going to put L1, assuming, of course, that the data is entered in L1. The frequency for our purposes is going to be 1. And that's always going to be 1 for the problems we're doing. And the C level, of course, is the level of confidence. Okay, if we have the summary statistics, we put the input on stats. X bar, of course, is the sample mean. SX is the sample standard deviation. N is the sample size. And C level is level of confidence. Okay, in the next video, as I said, we'll look at some examples of how to use this.